All right. So we're going to go over how to do cycle time calculations pretty quick. So first off, this is our instructions that we have here currently. And normally you'd probably draw this out in a really long chart and find out that it's like 49 cycles. And now you've wasted 15 minutes doing this. So one quick way that we are going to go about it is to do something like first, we would understand that there are two types of hazards, how we can find in these instructions. So first would be a consecutive, and the other one's a one hop. And these come in two flavors. They come in execute and load word. Now, execute and load word are just in respect to the types of instructions that may happen. So for execute, it's any of these over here, which may be an add, addy, mul, sub, whatever. But it's going to happen in this format, where we're going to have an add right after an add, or a mult right after an addee, whatever it might be, but next instruction always has that dependency on the last instruction. For a load word, it's similar concept, but now load words in there. Both of these should incur 2 delays, and the opposing one, or at least the pair, the other one is going to be the one hop. And there's also the same type of flavors in execute and load word. And both of these are going to incur 1 delay. And the difference is one hop means that the instruction in between the assign instruction and the dependent instruction has nothing to do with either of them. As we can see here, addy uses assigns to S0 and sub doesn't even touch it, but then S0 is trying to access again in the third instruction. So the way to go about calculating this, oh, actually one more thing too, anytime you run into a branch, each branch is going to be 3 control stalls, and then each time you run into a jump, it's going to be 1 extra control stall. And either way, you're going to have 2 delays, 1 delay, 3 delays, or 1 delay. And that's just going off of 2 delays, 1 delay, 3 delays, one delay stalls. So first we want to calculate how many instructions do we have? Or not calculate, but just count. We can do this by rolling out our branch and just figuring out how many instructions get executed. And we count here about 20. The way we calculate how many cycles at base that is the first one's always going to execute 5 cycles, and then each consecutive instruction is going to execute 1 extra cycle. So we can just add then 19, and that's going to be 24 cycles. Then we can start and say, all right, well, starting from the top, we notice already right off the bat, there is a raw read after write. So we delay 2. And because we delay 2 on this one, this instruction doesn't actually have a read after write. Though we end up having a 1 hop for these 2 instructions because we have another read after write, though its instruction separated. That one has nothing to do with S2. So right off the bat, we're going to have 24 plus 2 plus 1. Then, because this is a loop, we want to try to chunk this into how many times the loop has executed. So we see 12 get loaded into S2, then S2 is compared to T1 to see if they're equal, and T1 actually initially starts out as 0. So each time, if you just look at the loop, each time we're adding 4 to T1. So this loop, this section of code, should execute a total of 3 times. So we can go ahead and put in a multiplier for 3. So we'll do 3 times something. Start of the loop, we have branch. The branch is going to incur 3 extra cycles. So we'll put a delay of 3. Then we have a load word, and then we have a add. This is a read after write, and has an extra has a stall of 2. we see no extra stalls throughout here, and then we have a jump. So then we add 1. After this entire loop is done executing, and T1 and S2 are equal to each other, we're going to incur one more branch delay because we are still checking. So we're going to add 3. And then there's no more. And upon adding this up, actually I take that back. We do want to add 1 more that I didn't account for. And that extra 1 comes from, hold on, let me double check. Yeah, should just be from the branch equal. There was 1 control delay from that, from the jump, which I didn't add. So then adding up 24 plus 2 plus 1 plus 3 times 2 plus 1 plus 2 plus 3 plus 1 equals 49 cycles. And that's a quick way to try to calculate this. Hopefully that helps.